welcome to Maths for All. I'm Aisling Flynn. This is Trigonometry 1.2, working backwards. Find the angle. So in the previous lesson we were presented with various angles and we were asked to calculate or find their sine, their cosine or their tangent. In this lesson we're given the answers for sine, cosine or tangent of an angle and we're asked to work backwards to find the size of that angle. So how many degrees were in that angle? And here's an example to show you. If sine A equals 0.5, what is the angle? So we're given the answer for sine and we're asked to go backwards and find out how many degrees are in angle A. And this is how we do it. We can use our calculator. Okay, so if you look at your calculator more closely, and there are many different models of calculator, but you'll see the sine, cos and tan functions together. If you look more closely above them, you'll see what looks like sine to the power of -1, cosine to the -1 and tan to the -1 functions in yellow writing there. And these are the inverse functions of sine, cos and tan. So the inverse means that it does the reverse. So if you input the answer for sine, it will work in reverse to give you the angle that gave you that answer. Now to select those functions, on this calculator you'd press the shift button, which allows you to select the yellow writing on the calculator. And so in this example we use the sine inverse function. Okay, so you would press shift and the sine button to give you sine inverse. You would type in 0.5, press your equals button, and the calculator will return the angle A. So in this case A is 30 degrees. Okay, so it would be good to pause the video here and to try that on your calculator to make sure you can operate that function correctly. Okay, so as you go through your trigonometry lessons, you'll see that some of the same angles come up over and over again, and these are very common angles. Okay, and there's a page in your formula and tables books which may or may not be of help. Okay, and they give the answers or the values of cos, sine and tan for these common angles. So if we look here at the table below, we see the angles A, so 0 and 90 degrees are very common, 180 which is a straight line, 270 which is 3/4 of a full circle, and then we have 30, 45 and 60. So these always come up in various questions. And down the side then we see the values of cosine, sine and tan. Alright, so if we think of the question we've just done, we were told that the sine of the angle was 0.5. Now of course 0.5 is equal to a half. Alright, and if we look along the sine row of the table, you will see that we have sine of a half appears here. And if we track that upwards to the angle, we'll see, yes, it's 30 degrees was the angle that gave that sine. Okay, so for some commonly repetitive angles, you can get the answers from here. Underneath the 30 degrees is the same angle in radians. So occasionally you might be asked to use it, work in radians. Just be aware that that's there. Now let's return to our calculators and let's practice using the inverse functions. So question 1 here, sine A equals 0.5786, find A correct to the nearest degree. So I want you to take your calculator and type what you see. So using the shift button, select the sine inverse function and the bracket will open on your screen and you're going to type in this value here, 0.5786, and press equals. And let me just do that quickly. Let's see what answer we get. 0.5786. You can close the bracket, but it's not entirely necessary. and we get an answer, I get an answer of 35.3521, and it goes on and on and on. We were asked to give A correct to the nearest degree, so that's the nearest whole number. So we want to stop after 35 and look to the next digit. It is less than halfway, so we'll leave it as 35 degrees. Okay, now part 2 says if tan B is 1.8453, find B correct to the nearest degree. So this time what we're given is tan, so we'll work backwards with that, and this time we're using the tan inverse, so shift and the tan button, and we'll type in 1.8453. 1.8453, and when you press the equals button we get 61.5459, and it does go on a bit. Okay, again we were asked to give our answer to the nearest degree, so we'll be stopping after 61. If you look to the next digit, it is 5, meaning we're more than halfway to the next whole number. We're closer to 62 than we are to 61, so I'll write that angle B equals 62 degrees. That was angle A above. Okay, so that's your inverse functions. Practice those, check you're getting the same answers, and always check that your calculator is set to work in degrees. Okay, so some more practice. Look at the triangle on the right and say which ratio 3/5 represents. Okay, so we'll answer that bit first. So 3/5. Okay, so which ratio that's referring to? Is it sine, cosine, or tan? All right, now to answer that we have to label our sides. So straight across from the 90-degree angle, and the longest side is our hypotenuse, so 5 is the hypotenuse, and we're using angle A here, looking straight across at 3. That makes 3 the opposite. Okay, so we have opposite, which is 3, over hypotenuse, which is 5, and opposite over hypotenuse is sine. Okay, so sine A equals 3/5. Now that's the first task. Second task, express 3/5 as a decimal. Okay, so remember that 3/5 means 3 divided by 5. Okay, if you put that into your calculator, it'll give you back 3/5. Use your change button to change it to decimal. We get 0.6. Okay, so that's that task. 3/5 is the same as 0.6 or 6/10. Now then it says find the value of the angle A correct to the nearest degree. So what have we found out? We found out that we're working with sine of angle A, and we know the answer is 0.6. Okay, now we're going to work in reverse to find the angle A. Because we're working with sine, we'll use the sine inverse function. So shift and sine, type in your 0.6, and let's see what answer we get. And I get 36.86989, and it goes on another bit, and we're asked to give our answer to the nearest degree, so stopping after 36. The next digit tells me I'm more than halfway, I'm closer to 37, so angle A is equal to 37 degrees. Alright, so pause there, make sure you followed correctly, and try and do it on your calculator also. So another example here. Use the given right angle triangle to write down number 1 sine A and number 2 sine or tan A. Now find the measure of angle A correct to the nearest degree. We'll look at the numbers, the answer is going to be the same, isn't it? But let's go through it. I just want to look in particular at tan A also. So part 1 asked for sine A, and I always write down my ratio as sine is opposite over hypotenuse, some old hags or however you remember it. Okay, now to fill in the numbers I need to label my triangle. Again, across from the 90-degree angle, the longest side is the hypotenuse. Standing in A, looking across, gives me the opposite, and then beside me is the adjacent. Okay, so sine is opposite over hypotenuse, which is 3/5, and we can change that to decimal if we want. You don't have to. We can use the fraction button also. All right, we'll park that there for a moment. Okay, and we're going to write down tan A. Now tan is opposite over adjacent, their old age. Okay, and in this case that is 3/4. All right, and now we're going to use the inverse function of these to find out what angle A is. So in number 1 it was sine, so we're going to do sine inverse. Now we can change it to 0.6 as we did in the previous example, or if you use your fraction button, okay, remember that looks like this on your calculator, your fraction button. Okay, it's on near the top left hand side. You can type in 3/5 as it is, and it will give us the same answer as above, 36.86989, which we said was more or less equal to 37 degrees. Okay, now why did I want to do this example? I want to show you the tan inverse function. So repeat this on your calculator. Shift and tan gives you tan inverse, and put in 3/4, or if you prefer 3/4 is 0.75. You can use 0.75 either. And what you'll find is we should get the exact same answer, of course, because we're referring to the same angle. All right, so the point of this example is you can use any of the 3 ratios to find your angle. So you would use the one that you in the question that you have the information for. Now in this example we're asked to find a missing side, so find the side. Look at the triangle. We have the angle of 40 degrees, we have a side that is 8, and we have a missing side x. Okay, and we have an empty side we don't know anything about. All right, find the value of the side marked x in the given triangle. Give your answer correct to 1 decimal place. Okay, so we have a right angle triangle. We cannot use Pythagoras because we don't have enough sides. So we're going to use one of our ratios. Will it be sine, which is opposite over hypotenuse? Will it be cosine, which is adjacent over hypotenuse? Or will it be tan, which is opposite over adjacent? Now to make that choice, I always start by labeling my triangle. Okay, so our angle is here, it's 40 degrees. Across from the 90-degree angle and the longest side is 8, which is our hypotenuse. Okay, and the only other side of interest in this particular question is the x, right? So, and we're looking straight across at it. Okay, so this is the opposite, and we don't have any information about the adjacent, so we can't use that. So which of your 3 ratios involves O and H? And that is sine. So we choose this one. All right, I'll write it down over here. Sine of an angle is equal to opposite over hypotenuse. What we do next is we fill in the information that we do have, and then we'll work to solve for what we need, which is x. Okay, so in this case we do know angle A is 40 degrees, so we can fill that in. Sine of 40 degrees equals, now the opposite is side x, which we want to find out, and the hypotenuse is 8, so that goes in there. All right, so what can we do next? We do have an equation, remember, so we can do what we need to do, provided we obey the rules of equations and do the same to left and right. Okay, I can use my calculator to get a value for sine 40. So if I type in sine 40 equals, and you try that there on your calculator, I get 0.6428. I'm going to round it there. Our final answer is to 1 decimal place, so always go more than that and during your calculations, and at the end then you can round to 1 decimal place. Okay, equals x over 8. So how do we get x equals? Well, at the moment it's divided by 8. There's a denominator there of 8, and to get rid of that, or to move it, we're going to multiply left and right by 8. Okay, and why do we do that? Because 8 divided by 8 is 1, and so we get 1x equals to 8 times 0.6428. So we'll do that, and we get 5.1424. So pause and do that on your calculator. Make sure you're getting the same answers. Now, to finish off and give the answer that was requested, we'll round that. We want to stop after 1 decimal place. 4 is less than halfway, so it's closer to 5.1 than 5.2. So we'll say our x is equal to 5.1. Okay, pause, review, go back through the steps and make sure you can follow. So another find the side question. Find the value of the side marked x in the given triangle. Give your answer correct to 1 decimal place. So again, we have to look at our right angle triangle. We see that we cannot use Pythagoras' theorem because we don't have enough sides. So it's right angled. It's going to be one of the ratios. It always helps to write them down. Sine, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. Okay, next stage is to label our triangle. So here's our angle, 38 degrees. As always, across from 90 degrees, the longest side is the hypotenuse, and then we're looking at the side straight across from 38. It's 12, and that is the opposite. So it's opposite over hypotenuse. So again, it's sine, but you'll see that's a small bit different than the last one. Okay, so write down the ratio that you chose. Okay, and now enter in the information that you do know. So we do know the size of the angle, so we know it's 38 degrees, so we'll put that in. We do know that the opposite has a value of 12, and what we don't know in this case is the hypotenuse, which is called x. Okay, so it's similar but different. This time our unknown is underneath the fraction on the right hand side, so our manipulation of the equation will be a little bit different. Okay, firstly I can calculate the value of sine 38, okay, which is 0.6157, again using more decimal places than are required in the answer, equals 12 over x. So we're going to do what we did the last time with the denominator, so the number that's under the line. We're going to multiply both sides by it, so we multiply by x and x, because x divided by x is 1, and what we get there then is 0.6157 multiplied by x equals to 12. Okay, and to solve for x, we're going to divide by whatever is multiplied by it, 6157, and the same on the right hand side, because 0.6157 divided by itself is 1, and we get x equals the answer to this division. So we'll divide 12 by 0.6157, and I get an answer that is 19.49. Okay, and finally, look back to the question. We're asked for 1 decimal place, so we want to stop after the 4. Look to the next digit. It's definitely more than halfway. It's definitely closer to 19.5 than it is to 19.4. So we'll say x equals 19.5, and that's my answer. Okay, and that makes sense. It always is good strategy to review your triangle, look at it. It's not always drawn to scale, but if the opposite side is 12 and x is the hypotenuse, it should be longer than 12 without being a crazy big number, and 19.5 seems a reasonable answer for that. Okay, so you practice some work on that with your quiz and your written exercises.